All right, let's sum up our disjoint events with a real world application, something that in line of what I feel that you will be looking at on your upcoming assessment. Maya is playing a board game. She rolls two number cubes. If the sum of the numbers rolled is 11 or 12, she would get another turn. So what we want to do is we want to use a grid to find the sample space. Then find the probability that Maya will get another turn. Alright, so we got two steps that we want to do. First of all is we want to create, and I've done so, a grid to find the sample space. So here we're looking at first row, second row. First row, second row. On the first row we have chances 1, 2, 3, 4, 5, 6. Second row we have chances 1, 2, 3, 4, 5, 6, and 7. Where did the 7 come from? Because we can add 4 plus 3, 5 plus 2, 6 plus, and so forth. Then we have 2, which is 3, 4, 5, 6, 7, and 8. 3 we can add, and if you notice what's happening with these rows, we're adding one roll, you roll a 1, the second dice you may roll a 1, that's going to give you 2. First dice you roll a 2, and your second dice you could roll a 1, that's going to give you 3. And as you see, this is the first roll and this is the second roll, and what we're rolling adds up. Okay, so as we go on down, we'll see that if we roll we roll a 4, we could roll a 1 to give us 5, a 2 to give us 6, a 3 to give us 7, a 4 to give us 8, a 5 to give us 9, or a 6 to give us 10. If we roll a 5, the second roll, we could have rolled a 1 on the first one to give us 6, a 2 to give us 7, a 3 to give us 8, a 4 to give us 9, a 5 to give us 10, or a 6 to give us 11. Okay, and then on the sixth roll we could again roll a 1 to get us 7, 8, a 2 to give us 8, a 3 to give us 9, a 4 to give us 10, a 5, 11, and a 6, 12. So what the grid is actually just showing us from the first and second rows, that there is 36 likely outcome in the sample space. Should make sense. 6 on the first one, 6 on the second one, which will give us 36. So we have our sample space. So let's take a look at our sample space, and we're looking for her rolling an 11 or a 12. So I see 1, 2, 3 different outcomes. So my second step, what I'm looking for is what's the probability of me rolling an 11. So I can do so with a 5 on the first roll and a 6 on the second roll. I can do so with a 6 on the first roll and a 5 on the second roll. So that gives me the probability of an 11, 2 out of the total sum, 36. Now, as I look at the 6, well, the only way I'm going to get 12 is I must roll a 6 on the first roll and a 6 on the second roll. So that's only a 1 in 36 probability. So now I've came up with what I am looking for as far as my probability. And these are disjointed events. So why? Because 2 die. So we have the probability of the sum of 11, or the probability of the sum of 12, equals to the probability of the sum 11 plus the probability of the sum of 12. That's going to give me 2 over 36 plus 1 over 36. Notice I did not simplify the 2 over 36 to 1 over 18, because if I would, I couldn't add them until I went back and found my common denominator. They're already in that form. I will add 2 plus 3, not going to add the denominators. That's going to give me 3 over 36. Now I will reduce by dividing both numerator and denominator by 3, and I will get the probability that Maya will get another turn is 1 out of 12. that sums it up with what we are going to do with disjoint events. We will take a look in the future on experimental and probability, and pretty much sum up our discussion on probability before we move on to means, mode, and etc.